In this lesson, we're going to be solving equations with variables on both sides of the equal sign. This looks different than the last lesson because the k's are on different sides of the equal sign. In the last lesson, they were on the same side. Because they're on different sides, we're going to have to bring one to the opposite side. We are going to be doing opposites. Your goal with these is to collect the k's on one side or the other. It doesn't matter which one. So, just to start with this problem, let's bring this 5k to this side. Again, because we're bringing it to the opposite side of the equal sign, you do the opposite. Always look in front. It's positive, so I subtract. Okay, so I'm dropping down the equal sign. 7 minus 5 is 2k. Drop down the 18. On the left side of the equal sign, I have a negative 8. Once I collect the k's on one side or the other, it turns into a two-step equation. I need to bring the non-variable term over. Here is the same sign sum, so I'm going to go ahead and add those two together. And I'm going to separate. Okay. Let me show you another way to do it. This is the only problem we're going to solve the same problem two different ways. I'm going to prove to you that you can do two different things. So I'm just going to rewrite the same problem. 5k minus 8 equals 7k plus 18. So in this last problem, I brought this 5k to the right side. Let's see if we get the same answer if we bring the 7k to the left side. As long as we collect the variables on one side, we should be good to go. So this is a positive 7k. I'm going to subtract. Different sign difference. 7 minus 5 is 2, negative 2k. On the left side of the equal sign, I drop down to negative 8. On the right side, I have 18. I bring the non-variable term over. On the left side of the equal sign, I'm left with a negative 2k. Divide both sides by a negative 2. So k equals a negative 13. So they're proof that no matter which side you collect the variables on the left side or the right side, you will get the same answer. Let's try a different problem. M minus 1 equals 9m plus 15. Again, we're collecting the variables on one side or the other. I'm going to bring this m to this side. Look in front. It's a positive 1m, so I'm going to subtract 1m. Okay. On the right side, I have 8m plus 15. On the left side of the equal sign, I have a negative 1. Always take those signs out in front. This two-step equation, I need to bring 15 to the left side of the equation. Same sign sum. I get an answer of negative 2. They are going to want you to check your answer, so let's look at what that looks like. When you check your answer, you're going to plug the value in every time you see an m. So this was m. I have negative 2 minus 1 equals 9 times negative 2 plus 15. I'm solving both sides of the equal sign. There are two expressions here. On the left side, I have negative 2 minus 1, or keep switch opposite. Adding rules tell me same sign sum. The left side has a bigger expression. Multiplication first. Okay, negative 18 plus 15, I'm actually subtracting. Because both sides are equal, I know that this is the correct answer. Try 5n minus 2 equals 3n plus 6. Push pause and try that now. Okay. We may have to solve these different ways, so we should get the same answer. You can bring the 5n and collect them on the right side of the equal sign, or you can bring the 3n and collect it on the left side. When I solve these, I like to get positive answers. So look at what happens if I bring this 3n You see that my answer is positive? I like to plan ahead a little bit. You will get the same answer if you bring 5 in over here. Okay, so I have 2n, I have a negative 2 on the left side of the equal sign, and on the right side of the equal sign I have a 6. Bring the non-variable term over. And divide. Okay, check to see if you have an answer of 4. I'm going to check to see if our answers are right. Every time I see n, I plug in 4. 5 times 4 minus 2. Does that equal 3 times 4 plus 6? Solve the left side of the expression. 5 times 4 is 20. 20 minus 2 is 18. So now I'm going to solve the right side. 3 times 4 is 12. 12 plus 6 is 18. So I know that I solved this correctly. Okay, when we were solving equations in the last chapter, I'm trying to think, they were one step. So there is a possibility of getting different answers in one solution. I don't think we did this before. I think this is new. That's what I was trying to think through in my head. So let me show you something. And I'm pretty sure this is new. I know you learned this in 8th grade, but I think this is new to 7th grade. Sometimes instead of getting one solution, which we have in the past, you are going to get no solutions or many solutions. That's what's going to happen in this first one. 7 times the quantity 2x plus 3 equals 21 plus 14x. Before I can bring the variables to one side or the other, I need to do the distributive property on the left side. So here I have 7 times 2x and 7 times 3. I'm just going to drop down the right side. Now I'm going to collect the variables on one side or the other. It doesn't matter which way you bring them, to the right or to the left. I'm going to bring this 14x to the right. It's positive, so I'm going to subtract. But 14x minus 14 is 0. There are 0 x's. I'm not going to put x. They're gone. They're canceled out. Look at what we have left here. On the left side I have a 21, and on the right side I have a 21. When your variables cancel out and you get a true solution, there are infinitely many solutions to this answer. So I'm just going to say many solutions. Okay, meaning no matter what number you put in for x, this side is going to match. So let's just try it with 0. Let's try something easy. 2 times 0 is 0. 0 plus 3 is 3. 3 times 7 is 21. We get 21 over here. 14 times 0 is 0. 0 plus 21 is 21. Both sides are equal. I could put 100 in there. I could put a negative number in there. No matter what number you use for this equation, it's going to work. Okay, that's why you don't get x equals, because there's not one solution. There's infinitely many. The opposite would be this. 4 times the quantity, negative 2 plus 3x equals 12x. I need to solve the distributive property on the left side. 4 times negative 2 is negative 8, and 4 times 3x is 12x. Okay, I'm going to collect the variables. I'm going to collect them on the right side this time because there's not another term here. And what do you notice? Those terms cancel out. So think about what I have on each side of the equal sign. On the left side, I have a negative 8. On the right side, there's nothing. When your variables cancel out and you get a false statement, negative 8 does not equal 0, there are no solutions to this equation. So let's try 0 again. I'm going to plug 0 here, and it's not going to work. 3 times 0 is 0. 0 plus negative 2 is negative 2. Negative 2 times 4 is negative 8. We've got negative 8 over here. If we plug 0 over here, 12 times 0 is 0. Negative 8 does not equal 0. Let's plug 1 in, okay? 3 times 1 is 3. 3 plus a negative 2 is 1. 1 times 4 is 4, so on this side I get a 4. 12 times 1 is 12. 4 does not equal 12. It doesn't work. Nothing will work for this equation. So now when we're solving equations, you can get 3 different possibilities. You can get what we've always had in the past, and that's what we did up here, a variable equals one solution. And when that happens, you should write x equals 4, n equals 4. You should write that. You do not have to write one solution. When your variables cancel out, you will get many solutions or no solutions depending on if your statement is true or false.